simplifying radicals today. This is a little different than the previous 4 lessons, which are all on quadratics. But we're simplifying radicals or square roots for a reason. It's going to relate back to what we're doing. But before we start that, can you guys try this warm up? So solve for x and those two equations. That should be hopefully okay by now, right? We've been doing that for a while. Find where that crosses the x-axis and attempt this last one and see how far you get with that. Alright, so go ahead and pause the video and try this first page as a warm-up. Alright, so solving for x in these equations, right, when you see an x squared and an x in it, those are called quadratic equations. And the way we solve quadratic equations is we get them first into standard form, right, and we make them equal to 0. So let's do that first. So I'll distribute the 6 and get 6x squared minus 12 equals negative x. Next, I want this equal to 0, so I'm going to add x to both sides. Right, and I'm putting this x over here because I know that's going to be the middle term. Right, there's no like terms that I can add the x to. So that becomes 6x squared plus x minus 12 equals 0. And now I need to factor this to solve. So that was step 1, getting it into standard form and equal to 0. Right, step 2, we're going to solve this by factoring. So I notice the leading coefficient is a 6. That tells me let's use the AC method. So a times c, 6 times negative 12 equals negative 72. And I'm looking for two numbers that multiply to that and add up to my middle value, which is the b value, which is 1 here. Right, so we want to multiply to this and add to 1. So if you need to make a little table, go ahead and do that. But I think the two numbers are going to be positive 9 and negative 8. So we split up that 1x in the middle into 9x and minus 8x. We drop down the other two terms, 6x squared plus that minus 12 equals 0. Right, so as part of the AC method now, we're going to factor by grouping. Group and group. GCF of 6 and 9, they have a 3 in common. X squared and x have an x in common. Factor out a 3x, we're left with 2x plus 3. Alright, GCF of a negative 8 and negative 12. If that's negative, right, we're going to pull out a negative with it. So I'm going to factor out a negative 4. And that's going to be 2x plus 3 as well. And these two better be the same. We can pull out a 2x plus 3 times 3x minus 4 equals 0. Right, tee it off and solve. So 2x plus 3 equals 0. 3x minus 4 equals 0. Right, using a zero product property, either of those factors are equal to 0. So on the left, 2x equals negative 3. X is negative 3 halves. 3x equals 4. X is equal to 4 thirds. Alright, that is solving. So that was just a quick review on that. This one over here. Hold on, I'm about to sneeze. Okay, that didn't come out. But alright, so here, this next one, first step, get it in standard form, which it is, and also get it equal to 0, which it is. So the first step is done for us already. So step 2 is just to factor, right? And factoring, we're always going to look for a GCF first, and 8 and 18 have a GCF of 2. So I can factor out a 2 and get 4x squared minus 9. Alright, so I have 2 times. Think about 4x squared minus 9. Alright, if you need to pause the video, what kind of factoring is that? Alright, if you said dots, that is correct. That has a difference of 2 perfect squares. Square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3. Alright, one's plus and one's minus equals 0. Now that it's factored, I can use the zero product property, right? No answers from 2, 2 can't equal 0, so ignore that. 2x plus 3 equals 0, 2x minus 3 equals 0. I'm just going to jump to the answer. We get negative 3 halves and positive 3 halves. Alright, so 2 quadratic equations, solving them. Next, find where this function crosses the x-axis. So if I want to find where it crosses the x-axis, think about what we're trying to find graphically. Right? So if you have a parabola, we want to find where it crosses the x-axis. Well, what we're looking for are the x-intercepts, right? Or the roots. So looking for the roots, or the x-intercepts, we set the y value, or our function f of x, equal to 0. And just like before, the way we solve this equation is by factoring. So x plus 6 and x plus 2. Right? 6 times 2 equals 12. 6 plus 2 equals 8. Right, so AC method wasn't needed for this one because our coefficient here is 1. Right, it's a 1x squared. So teeing this off and solving, we get x equals negative 6 and x equals negative 2. So no problems here. Right, if I make a really quick sketch, it means the graph is going to cross at negative 6 and at negative 2. Alright, so next one, find the zeros of x squared plus 9x plus 12. Alright, this one was pretty simple, hopefully. Right, this is the same question. I'm looking for the zeros, which again are the x-intercepts. Right, or the roots. So the only difference is that this 8 became a 9. So let's try to factor this. We're going to solve it the same way. Right, we make our function equal to 0. X squared plus 9x plus 12. So let's find two numbers that multiply to 12 and add to 9. And let's run down the list. 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2. Alright, so we're done. And what I notice is none of these numbers can add up to 9. I can't make 9. So what happens when we try to factor this? What happens is we can't factor it. Right? It's not factorable. So what the heck does this mean? All we did is change an 8 into a 9, and then, well, this was a nice graph. What the heck does this mean? So does this function have any x-intercepts? How can we check? Right? Does this function, g of x equals x squared plus 9x plus 12, still have x-intercepts? All we did is change an 8 to a 9. So, I don't know. I'm going to check by graphing it. So let's get on Desmos. Alright, there we go. Projector mode. Alright, I'm going to graph f of x first. That was our first function. So f of x, right, was equal to x squared plus 8x plus 12. Right, and that one was no problem. Zeros at negative 2 and negative 6. Right, if you wanted to find the vertex, you can find the average of the two zeros. In between negative 2 and negative 6 is negative 4. And the vertex is negative 4, negative 4. Right, now let me type in our next function, g of x. And let's see what happens here. Alright, so type this in yourself on your calculators. And let's see what this looks like. Plus 12. Alright, it looks just like f of x. Right, it still has zeros, it still has a vertex, it's still a parabola. So why was this not factorable? Well, let's find the zeros here. The zeros are negative 1.682, or 628, and negative 7.372. Huh. Interesting. Very interesting. Well, the 0 is actually not even those numbers because these are not exact. The zeros are actually negative 9 over 2 plus the square root of 33 divided by 2. And negative 9 over 2 minus the square root of 33 divided by 2. Right? Check out that 0. That 0 is negative 1.627718676673. So, how the heck are we going to get that? Well, that we're going to talk about later. But these zeros, right, these zeros are not nice zeros. These zeros are actually irrational. If you remember back to the beginning of the year, right, irrational numbers, those are numbers that have no pattern and don't repeat as a decimal. They can't be written as a fraction of integers. So that happens because of the square root of 33 here. So thus far, all the problems we've done, we've had nice rational zeros. But in this problem over here, we have irrational zeros. So actually, I want to take a picture of this to put into my notes. So give me... I think I have a screenshot. Alright, one more. Alright. So add from my photo library. And let's add this one from today. So, to answer the question, does it have any zeros or x-intercepts? Sure it does, yes. And I can't write on this. Yes. Right? But the zeros are irrational. Right? They involve radicals. Alright, so our 0 here was actually this number. Negative 9 over 2 plus radical 30, divided by 2. And don't worry about how we get that answer yet. I just want to show you why we're talking about radicals now all of a sudden. And this is why, because if we have irrational roots, there are going to be square roots involved. Alright? So, today's lesson, we're going to simplify radicals. So, a radical, or a square root of a number, is a value that when multiplied by itself gives the number. I think most of you guys know this. But for example, 4 times 4 equals 16. So the square root of 16 is 4. Right? Note that negative 4 times negative 4 is also equal to 16. But the symbol square root always indicates that we're only talking about the positive square root. So find the following square roots. So what number multiplied by itself gives us 100? Alright. It's 10. 10 times 10 is 100. The square root of 100 is 10. What number times itself gives us 49? The answer is 7. 7 times 7 is 49. Right. Take a second and think about these two. What times itself gives me x squared? And what times itself gives me x to the 16th? Alright, so the square root of x squared is going to be x. Because x times x equals x squared. Right? For this next one, a lot of people are going to say x to the 4th, right? Because 4 times 4 is 16. But let's think about that for a second. X to the 4th times x to the 4th. Do you guys remember your exponent rules? What is this equal to? Right. This is equal to x to the 8th. Right? Because x to the 4th again is x times x times x times x times another x to the 4th is x times x times x times x, right? And that is clearly x times itself 8 times, or x to the 8th. So x to the 16th is x to the 8th, right? Because when we multiply, we add the exponents, and 8 plus 8 is 16. Alright, so those are fine. And we are able to take the square root of those numbers because those numbers are things we call perfect squares. Right? A perfect square is something you can take the square root of nicely, like 100, like 49. So if you list out the first 12 perfect squares, well, actually, you're going to skip the first one. The first one is going to be the square root of 1, which is 1. Right? But the next one, the next number we can take the square root of is 4, because 2 times 2 is 4. Then we can take the square root of 9, because 3 times 3 is 9. And then it's 16. And then it's 25. Right? So all these numbers are just coming from 2 squared, 3 squared, 4 squared, 5 squared, etc. So these numbers here are perfect squares. Right? These are numbers that have a nice square root. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. Right? So if you drew a square root over any of these numbers, right, you would get a nice answer, like so. And these numbers we call perfect squares. So square rooting these numbers is very simple. You can type into the calculator, you'll get an answer. But what if the number we are trying to square root is not a perfect square? Well, what we're going to do in that case is simplify it. So for example, what is the square root of 50? Well, we would not be able to do that in our head. I would know it's going to be a little more than 7. It's going to be 7 point something, because I know the square root of 49 is 7, right? So the square root of 50 has to be just a tiny bit more than 7. And actually, if I type that into my calculator, I get it's about equal to 7.0710678118655, something, something, something. All right, but I don't care about that answer. What we're learning today is how to simplify it. So if it's not a perfect square, we're going to simplify the square root. I'll just write simplify it. All right, so the way we're going to simplify it is we're going to look for a perfect square that does divide into 50. So if you look at this list, 4 doesn't go into 50, 9 doesn't, 16 doesn't, 25 does. All right? So what we break this down into is we can change 50 into 25 times 2. So the square root of 50 is equal to the square root of 25 times 2. So hold on, let me write it like this. Square root of 25 times 2. All right? A rule that we can do for square roots is we can break it up into 2 square roots, like so. Square root of 25 times square root of 2. And the reason we're saying we're simplifying it is we took stuff out of the radical. Because what is the square root of 25 now? Well, that's a perfect square, and that's going to be 5. So the square root of 50 is equal to the square root of 5 radical 2. All right, so take a second and type in the square root of 50 into your calculator, and also type in 5 times square root of 2, and you should see you get the same answer. All right, they're both equal to 7.07107. All right. Let's simplify the square root of 200. So again, we're going to look for a perfect square root that divides into the number. A perfect square that divides into the number. So for 200, you might say, oh, 4 divides into 200, so let's use 4. And that is fine. Right? We can make it 4 times 50. And square root of 4 is going to be 2, right? But before I do that, I'll break it up one step more, like this. And square root of 4 is 2 times the square root of 50. So just 2 radical 50. But didn't we just simplify the square root of 50? Yeah, we can keep going further, right? Square root of 50 is 25 and 2. So I'm going to break down the square root of 50 into the square root of 25 times the square root of 2 still. And we still have this times 2 in front, so it's 2 times the square root of 25 times the square root of 2. 2 times the square root of 25 is 5 times the square root of 2. 2 times 5 is 10, and so that is 10 radical 2. Alright, and this is equal to that. You can type both into the calculator, you should see the same result. And that is how you simplify a square root if it's not a perfect square. Alright? So what we did here was actually not smart though, because we took out a 4. So what you want to do when you simplify something like the square root of 200 is to look for the largest perfect square. So you might realize, oh, 25 also divides into 200, but even better than that is 100. 100 times 2 is 200. 100 divides into the square root of 200. So let's say I broke it up into square root of 100 times the square root of 2 instead. Well, what's the square root of 100? That's 10. 10 radical 2, and I am finished. We got the same answer. So when you simplify a radical, right, something that's not a perfect square, what you want to look for is the largest perfect square that divides into the guy underneath the square root. So look for the largest perfect square that divides into the, right, I'm going to throw a vocab word at you. That number underneath the radical is called the radicand. Right, so look for the largest perfect square that divides evenly into the radicand. So the radicand here is 200, for example. The radicand here was 50. So we looked for the largest perfect square that divides into 50. That's 25. And then you can take the square root of 25 to simplify. Alright, so technically you don't need the largest one. It's just recommended to get the largest one because it makes it a lot easier, right? If you're looking for the largest one but you don't find it and you find something smaller like 4 or 25 first, you're going to have to do multiple simplifications, which is fine. It's just you got to be careful to keep checking your radicand to see if it can be simplified further. Alright. So that's it. That was pretty much today's lesson. That's simplifying square roots. At this point in class, I'd probably go over like 3 or 4 of these with you guys and have you guys try the rest. So that's what I'm going to do here. And I'm just going to write out the answers for the rest of them quickly. So I'll pick a couple to do. Let's do letter A. So square root of 75. We're looking for the largest perfect square that divides into 75. If you're not sure, that's why we listed out the first 12. So using a calculator could help if you're not sure what divides into 75. I mean, 75 is a pretty easy one though, so I'm sure you know it's 25 times 3. Alright, so we break this down into the square root of 25 times the square root of 3. Right, both under square roots. This is a perfect square, so once you take the square root of it, the square root is gone. The square root of 25 is just 5. So simplified, it's 5 radical 3. Right? When two numbers are next to each other like this, it implies multiplication, so you don't need to put the little dot. You can just leave it like 5 radical 3. Let's try another one like square root of 324. So I actually don't even know myself what divides into 324. So let's start with a bigger number. And if you start with 81 and you type that into your calculator, we actually get 324 divided by 81 equals 4. So we can break this down into the square root of 81 times the square root of 4. And if I do that, I get the square root of 81 times the square root of 4. But wait, what is the square root of 81? 9. What is the square root of 4? That's 2. Which means 9 times 2 is 18. So this here, that means 324 is a perfect square. It's just equal to 18. That means 18 times 18 equals 324. If you want to check that on your calculator, you can. You can also just type in the square root of 324 straight into your calculator. You also get 18. So this one we really didn't need to simplify using these kinds of methods, right? But even if we use the method, it still works out. 9 times 2 is 18. All right, let's try letter F now. What's the largest perfect square that goes into 108? All right, so if you're not sure, I'm just going to type these values into my calculator. What is 108 divided by 49? 2.20408, that's not a nice number. So I'm going to try 108 divided by 36. Right, you always want to start with bigger numbers first and work your way down because you want to find the largest perfect square. And aha, that's equal to 3. Alright, so we can break this down into the square root of 36 times the square root of 3. Right, because 108 divided by 36 was 3, which means 36 times 3 is 108. Oh, and also, you always want to write the perfect square one first, right? Because that's the one you can take the square root of. So that's what's going to come out. So the square root of 36 is 6. So that's equal to 6 radical 3. All right. I'm going to do this one other way. Let's say you missed 36 by accident and you didn't see that was the largest perfect square, but you found 4 divides into 108. And you found 4 times 27 is equal to 108. So we could break that down to the square root of 4 times the square root of 27. And we're going to get 2 times the square root of 27. But we did not find the largest perfect square, which means this radicand of 27, it means we can simplify that radical as well. That's going to become square root of 9 times square root of 3. So that's 2 times square root of 9 times square root of 3. I just brought down to 2. Square root of 9 is 3. So 2 times 3 is 6. Times radical 3 is 6 radical 3. And again, same answer. This one with the largest perfect square. This one if you missed it and you pulled out a 4 instead. Alright, let me do one of these with a coefficient in front. A lot of these have 25. Alright, let's do letter H. Alright, 175. You see a number like that, 25 probably goes into it. So I'm going to break that down to square root of 25 times square root of 7. And again, that 2 in front just means multiplication, so just bring it down. Kind of just ignore it at the beginning, right? Simplify the square root first. And don't forget about it afterwards. You're going to bring down to 2. So this is just 2 times 5 times the square root of 7. That's 10 square root of 7. All right. And then down here, this is with our variables. You want to think what times itself will give us x to the 6th. And the answer is x to the 3rd. Right? X to the 6th equals 1, 2, 3, 4, 5, 6. X times itself 6 times. And that means x cubed times x cubed equals x to the 6th. Because that's x cubed and that's x cubed. So this one here, letter K, this one is pretty interesting. Alright, this is kind of like a little extra. Right, if we want to simplify the square root of x to the 7th, Well, what was the procedure for simplifying square roots? It was to look for the largest perfect square that divides into the radicand. Nicely, evenly, right? So, like, technically you could say x to the 3.5, because x to the 3.5 times x to the 3.5 equals x to the 7th. But that's not what we're going to do. If you want to simplify this radical, right, we know x to the 6 was a perfect square, because that was equal to x cubed when we square rooted it. So what we could actually break this down into is square root of x to the 6 times x. The square root of x to the 6 times the square root of x. And the square root of x to the 6 is x cubed. So this is equal to x cubed square root of x. Alright. And again, this one is a little extra. If that doesn't really make too much sense to you, that's alright, but I wanted to show you that anyway. And that's going to be it. I'm just going to do the rest of these problems without speaking, just in my head. So let's do it. So if you want to check your answers, I would go ahead and try these problems on your own. But this is what it would look like for each one. Alright. Boom, boom. Radical 8. Rad 4 times radical 2. That's 2 rad 2. Those are done. This one. Right, square root of 25 is 5, so that's 3 times 5. That's going to be 15. That's going to be 36 and 2. Right, square root of 36 is 6. 4 times 6 is 24. And this last one, square root of 16 is 4. Square root of x to the 10th is x to the 5th. Alright, so that's it for today. Simplifying radicals. We'll be using this with quadratics. So make sure you don't forget what we learned earlier. Right, this is kind of like a side lesson that we need, just like skill-wise, for what we're about to do next. Alright, so make sure you can simplify square roots well, and I will see you guys next time. Alright, stay safe, and